let us continue the discussion about Docker that we were having. Okay. So let's talk about how will we build a Docker image, what a Docker image is, what do you do on that. Okay. So till now we have a Docker file. Okay. Now what this Docker file will do is this Docker file will have instructions. Okay. Will have some instructions on how to create. These instructions will lead to something called creation of a Docker image. Okay. And now Docker image will lead to something called a Docker container. These are the three terms that are very important for all of you to know. Okay. What is a Docker file? What is a Docker image? What is a Docker container? See, typically, when you download an application, when you have to run Google Chrome on your machine, do you download the code of Google Chrome or do you just download the .exe file of Google Chrome? If you have to run Google Chrome on your machine, do you download the code of Google Chrome or do you download the exe file of Google Chrome? You download the exe file. Okay, so now try to build analogy of this as this is the code of Google Chrome. This is .exe file of Google Chrome. And this is Google Chrome that is running. Google Chrome that is running on your machine. Running on your machine. Okay. Perfect. So what do I mean by this? See, now what will happen is in Docker file, you will write a lot of instructions to create something called a Docker image. Now what is this Docker image? This Docker image, if you download on your machine, okay, so what you do is, see, let us say this is your machine. Okay. Now on your own laptop, you want to run MySQL. If you want to run MySQL on your laptop, what will you do is you will download. So first of all, let us assume that in your laptop, obviously you have an operating system installed. And other than operating system installed, you also have Docker engine installed. You have also installed Docker engine. Perfect. Now what will you do is to this Docker engine, you will give the Docker image. You will give the Docker image. Now when the Docker engine will get the Docker image, it will run the application in the exact same way. Run the application in the exact same way. What do I mean by the exact same way? Exact same operating system, exact same dependencies, exact same files, all of those things as the developer wanted it to be. As the developer wanted it to be. Okay, let me explain that. So what will a developer do? What will a software engineer typically do? So typically this is a work that either is done by a software engineer or is done by a DevOps engineer. So what will happen is the code will be written. Okay? Now who will write the code? The code will be written by a software engineer. Now after the code is written for this particular code, for this particular application, depending upon if the code is in Java, depending upon if the code is in Python, Node.js, whatever language, either the DevOps person or the software engineer will create a Docker file. So within this code, there will be multiple files, and the software engineer or the DevOps engineer will create a Docker file. Okay, one of them will create a Docker file. Okay, perfect. Now in this Docker file, what will they do? In this Docker file, they will write instructions on how to create a Docker image for our application. On how to create a Docker image for our application. Okay. Now, while I explain the next concepts, how many of you have Docker already installed on your machine? How many of you already have Docker installed on your machine? Do a thumbs up if you already have Docker installed on your machine. Do a thumbs down if you don't have Docker installed on your machine. Okay, 50% people do, 50% people don't. Let me actually send you instructions to download Docker. Perfect. So do what? Go to this particular page. There is a link to page that I have sent in the chat. Just go to this particular page and you will get the download now button Using this download now button, you will be able to install Docker. Okay, so all of you, while I explain the next concepts, okay, please install Docker in parallel. Please put Docker to be downloaded in parallel. Okay, perfect. Okay, let's check if it is installed or not. So Ashish, in your all applications list, if you are able to see Docker, it is installed. If you are not able to see, it is not installed. As simple as that. Perfect. So go to this particular link, the link that I've sent in the chat. Go to the URL, click on the download now button. In parallel, put Docker to installation. Okay, super. Now, what will happen is, using this code, for this code, we will create a Docker file. Docker file will basically be instructions on how to create a Docker image for our application. This will basically have all of the instructions of what commands to run. Okay, what commands to run, what port to open, all of those kind of things. Okay, what port to open, etc. Perfect. Now after that, using this Docker file, you will create something called a Docker image. Now what is a Docker image? Docker image is a distributable. This is what you distribute. Distributable application that Docker can itself run. So what is there is, think of Docker image as the .exe file or .dmg file, the file that you use to actually install an application. This is the code of the application, but this is what you do, what you use to install that application, to run that application. Okay, Docker image is also that. Docker image is going to be a big file. Okay, Docker file is just a set of instructions. It is just kind of a set of instructions. It's just going to be probably a 1 KB file. Whereas Docker image is going to be a hefty file. What do I mean by a hefty file? It will actually contain all dependencies, etc. in a packaged way. Okay, what do I mean by it? So see, today I try to run an application. Okay, now when I'm trying to run an application, when I'm trying to build an application, let us say I have told that from this particular URL, bring a file, put that particular file to this particular place. Let us say 3 years down the line, is it possible that that URL is no longer working? Arjun, I'm not saying that it contains the code, right? It actually contains the things that can run. It is the exact thing that has to be done. Okay. Now, what is there in the Docker image? Docker image actually contains everything in a package. Now, everything that is needed to run that application at the end is present within this Docker image. Okay. So, Anjanish, it might contain the code, it might not contain the code. It might typically, for example, contain actually those files. For example, it will contain the binary code. Okay, that can happen. Okay. So, Docker image is actually the packaged version and contains everything that is needed to be able to run your application. Okay, this is what the Docker image is. That means if you don't even have internet connection, but you have the Docker image downloaded, will you be able to run the application if your machine has Docker? If you don't have any internet connection, you don't have anything, the answer is yes. Docker image contains everything. Okay, it is packaged, comprehensive, that is why it is typically going to be a hefty file. It's going to be a big thing because it contains all of the dependencies. Okay. Cool. But do you keep this .exe file on your machine? Or using this exe file, you install the application and the work of the exe file is done? Absolutely, it will contain all of the node, npm packages, etc. as well. Okay, cool. So what you do is, you just run that .exe file, and after that the purpose of exe file is done. So what you do is, when you have this Docker image, you run the Docker image. Okay. And when we run the Docker image, finally our application is running on a machine. So what happens is, we have a code. For that code, we create a Docker file. Okay. This Docker file is basically a set of instructions. It is a set of instructions. It is a set of instructions on how to be able to distribute this application. Okay, how to package this application in a way such that if this application is tomorrow run on any computer that just has Docker, the application should run in the exact same way as the developer wanted it to. Okay, so using this code, you create a Docker file which is just instructions. So very small, maybe KB file. Okay, using this Docker file. Okay, now when you have this particular Docker file, what will you try to do? You will try to create a Docker image. Okay, perfect. This Docker image is a packaged, independent, comprehensive thing. It contains basically everything. Okay, that means it will probably have size even in GBs. Absolutely good. Because it contains everything. It is going to contain everything that is going to be needed to run your application. And finally, when you run this image on Docker, what does it end up becoming? It ends up becoming a Docker container. So when you run a particular image, it ends up becoming a Docker container. Is that clear? Why can't we share Docker image directly? You do. In fact, that is what you share actually, Pawan. I will show that to you today. So now, let us actually see this journey ourselves. We have our code already. We just now started to create Docker file. Let us create the Docker file. Let us build that Docker file to create the Docker image. And let us try to see this Docker image in action as well. Clear? Perfectly suited? Perfect. So let us start with the topic. So would you please explain again? Arey, wait. I'm going to get all of you to run this. Okay, wait. How many of you are now having Docker installed? How many of you have installed Docker now? So let us start starting with this. Okay, so see, in my code, if I go here, I am currently on Java version 17. So I'm using Java version 17. So what I will do is I would want to start from a pre-made image. I would not want to start from scratch. I would want to start from a pre-made image. So what I will do is if you go here, if I go to my Docker hub, go to this place, hub.docker.com. On hub.docker.com, you have OpenJDK. Okay. OpenJDK is there. This is OpenJDK. Now in OpenJDK, there will be a tag of Java 17, I think. So there are many versions. I think I would just need an overview. Maybe let me click on any one of them and just let me try to, just a moment. So if you will see here it is actually mentioned, right? And these are the different kinds of tags that are there. So what we will do is I want to start with Java 17. So the only thing that I have to do is something like this. Here. Okay. So if I go here, someone is saying, can we check for node? Very sure. If you go here, okay. Just node. Yep. So if you go here, all of the versions of node, 17, 18, 20, 21, all of the versions of node exist here. Okay. So you will be able to see all of them. Anyways, getting to the topic. Okay. Perfect. So if I go here, let me go to my Docker file. I will say that, hey, I want to start from an environment where there is already Java 17 installed. So what is this particular line going to do? This line is going to say that, hey Docker, to create the Docker image, first get everything that is needed to be able to get Java 17. Is that clear? So basically it will install Ubuntu, it will get Java 17, everything will be there. Perfect. Now when you have this particular thing, now here I am creating image. Docker file is going to lead to Docker image. What I'm going to do is in that particular environment, add a particular file. For example, I'm going to say something like this, right? Maybe copy, and copy what? Maybe I will give the path of this particular thing. I will say copy path, copy absolute path. So in my computer, there is this particular file. Try to copy that. This thing should work. Cool. And after that, maybe just say, and I think that should work fine. I think that I should just say entry point which is this particular file. This should work. I just hope it works. Build command C. Let us try to run this version. Is it working? Cannot connect to Docker. Okay, what is happening on my computer? So Ayush, to get the target folder, you have to go to Maven. Go to the Maven here. Sorry, where are we? Go to Maven here. In Maven, in Lifecycle, double click on package. You will get that particular file. Okay. Cool. So I think my Java should be, my Docker should be running. Docker should be running. Why are we not getting this? Yeah, connecting. Now it should be working. Just wait a few seconds. It is preparing. Failed to deploy. Docker file pass error. Copy requires at least 2 arguments. App.jar. This should work. And let me just say app.jar. Let me try to run this. Can't retrieve image ID from. Sorry, I think I'm doing something wrong. Just give me a moment. Actually, on Spring article, where was that? Let me actually copy this. Perfect. Cool. I just need OpenJDK 17, and I can just copy this particular thing. I think this was the name of the URL. Just trying to find that path. Yeah. And I think it should work. Let me do that now. Why is it not working? Error response, copy failed, file not found in build context or excluded by .public node. Achha. Why is this not working? Actually, yes. Wait a moment. Target slash this should work. Perfect. Worked. Super. So what we have done is we just wrote a set of instructions. Using those instructions, using that particular Docker file, what happened? Here, what did it do? It created an environment, and in that particular environment, I think you did not even need this particular line. If I would have done that again, I think it should have worked perfectly fine. Work. Cool. So let us see what these instructions are doing. These instructions are saying that, hey, I want to create a Docker image. What is a Docker image? I basically want to create a package that contains everything that is needed to run my Spring Boot application. So what will I do? First, I want to create an environment. I want to get everything that is needed to run Java 17. Now, behind the scenes, do you think it is possible that this from OpenJDK colon 17 would have installed Ubuntu 22, would have installed Ubuntu 20, all of that? Is that possible behind the scenes? Absolutely great. That is possible, right? Because to run this Java 17, obviously you would have to install Ubuntu 22, Ubuntu 20, whatever. I don't care about that. So I created an environment that has Java 17. After that, in that particular environment, I copy pasted this file. In my target folder, there is this particular file. I copy pasted that file and called that app.jar. There was a very big name in that particular place. I called that app.jar in the package. Now, what did I say to Docker? I told that, hey, once you have this particular environment ready, where there is everything that is needed to set up Java 17 and this file, which is called app.jar, please just run this command called java-jar/app.jar. Just run this command and my application is up. That is all that you are saying here. Is that making sense? Is this making sense? Why do you put array? So see, this is the syntax of it. The syntax of entry point says that if you have a command like this, which is, let us say cp a.b.b.c, something like this, you have to call it something like this. Entry point. This is just the syntactical details. I don't have any control here. cp, comma, let us say a.b, comma, b.c. This is what I'm saying. Okay? So that is how the syntax of entry point works. Is that making sense? What was that jar file? So now jar file is how? Okay? Jar file is basically the file that contains everything that is needed to run that Java application. It contains all of the dependencies. It contains all of the third-party libraries, third-party code that you have put in your application. Okay? What about spacing? Sort of doesn't matter. Okay, so it basically automatically will append spacing between them. Okay. So what we are doing? We are saying that create an environment that has everything that is needed to run Java 17, whatever operating system, I don't care about that. After that, copy this particular file into that particular environment. Okay. Now, after this file has copied, when a person tries to run this Docker image, when the person will try to run this Docker image, run this command. Everyone clear till here? So whenever the person will try to run this Docker image in that environment that you have created, in that environment, just run this command. So if you have to run the command called this, which is java-jar/app.jar, in that particular case, do this. That's it. So this command will run whenever the person will try to run this Docker image. Perfect. Now, what I have is I have a Docker image. So I have a Docker file. Using this Docker file, I will be able to create a Docker image. See, here I am creating the Docker image using my IDE. But there are other ways as well in which you can create this particular image. What is that particular way? Which is using terminal. So in terminal, what I can do is I can run a simple command. For example, I can run a command like this, docker. Are you able to see my terminal perfectly fine? I think now you should be able to see. Unfortunately, I'm not able to zoom up, but you should be able to see, right? So what I say is that see, in this folder, which is product service PTS morning folder, I have a Docker file. Okay. Now run a command something like this, docker build -p, and whatever you want to call that particular image. See, when I will create an image, would you want that image to be distributed to other people? Would you want that image to be distributed to other people? Absolutely right. You would want that image to be distributed to other people. Other people should be able to see that image. Other people should be able to probably download that image and do some work. Okay. Now that image might be public, image might be private, depending upon what the thing is. For example, if Google is creating a Docker image of something, would Google want that image to be public? Would Google want that image to be public? Obviously no. For example, Google for an internal software, they would definitely not want anyone to be able to run that software. But maybe, let us say, if it is an open source project, would you want the image to be public? Are you Gautam? I'm showing that to you. Yes, you would want that to be public. Super. Now, how do you create the image? To create the image, you have a command called docker build. Okay. So, after doing docker build, for example, let us just call this my app. So, docker build, exactly what happened. Sorry, not. Cool. Now, did you see something happened? There was some image that was created. It read this particular Docker file. After reading this Docker file, it went through all of this and it wrote an image. Okay, it wrote an image. Okay. Now, what is this particular image? What is this particular image doing? At the end, I would want this particular image to be visible to public. So what I will do is Docker provides something called Docker Hub. What is Docker Hub? Docker Hub is exactly like GitHub. In GitHub, what can you push? In GitHub, you can put the code that you have written in a Git repository. Yes or no? In GitHub, can you push any code that you have created in any Git repository? Absolutely right. Similarly, Docker has Docker Hub. In Docker Hub, you can upload your images. In Docker Hub, you can upload your images. So what I will do is, Umesh, there are alternatives for Docker Hub as well. For example, for GitHub, there are multiple alternatives. There is GitLab, there is Bitbucket. Similarly, for Docker Hub as well, there are multiple alternatives. For example, I think Amazon has something called, I forgot the name. Amazon also has something called, JFrog is something else. Amazon, what was the name of Amazon? ECR, right? Amazon has ECR, so that is also the exact same thing. Okay. So let me actually go to my Docker Hub. So if I go to this place, on this place, if I go to hub.docker.com, let me sign in. Continue with Google. Sign in Google as this. I think my account should already be there. Why is it not doing that? Just give me a moment. Docker.com. Sign in. Continue with Google. Perfect. Super. So if you are able to see my screen now, are you able to see my screen? Are you able to see my screen? Perfect. So what I have is, I already have an account on Docker and my username is Naman. So what I want to do is, I want to have the image that I'm creating being visible on Docker Hub. So what I will do is, I will tag that image with that name. So for example, I will do something like this. I will come here, I will say Docker build. My username is Naman, so Naman slash. Then I will call what I want to call that repository. So for example, I will say my product service masterclass. Dot. Perfect. What is happening now? Sorry, I missed it. That should work. Perfect, cool. Why is the Docker not logged in? Why is the issue coming? Why is it asking me to log in? I had set this properly before this class. Just trying to see why this is working bad. Actually, there is a problem. This should work. Open Docker. Now it should work. Just give me a moment. Control C. I think it will work now. Perfect, worked. So if I do this, super. So what it has done is, it has created this particular image. So what it has done is, it has created an image. Its target, basically create an image, and this should be what the final name of that image should be. Naman Bhalla / this. That's just the name that I've given. Clear? So users can interact with the image or hosted app on Docker Hub instead of running on Fiddling. No. Enough. So Docker file is what will lead to creation of the Docker image. Now Docker image is used after that. So anyone who wants to run the application after this, they don't even need anything else. The only thing that they need is this particular Docker image. They will get the Docker image on the machine and they will be able to run the application. Sarthak, this whole code that you are seeing on your screen right now, I will be sharing with you. Don't worry. Okay, getting there. Okay, see. Till now, this image that I have created, is there anywhere uploaded button? Is there anywhere upload written? Is there any way upload written? The answer is no. Upload is not written anywhere. Because I have just created the image. Have I pushed this image yet to Docker Hub? The answer is no. I have not yet pushed this particular image to Docker Hub. So what I will do is, now I will try to push that. So what I will say is, okay, Docker push Naman Bhalla / this is what I want to push. One. Perfect. Wait for some time. Just wait a few times. It is uploading the code there. And now, are you able to see that it's actually a very big code, 49.26 MB for this, some other code for this, some other code for this. So Docker image, uploading a Docker image is not very fast, because it is going to be a big file. It is going to be a hefty file. It contains everything that is needed to run my application. Okay. T has one specific purpose. Every command has a syntax, Nitya, and how you can do that is just wait a moment. Docker push command. So for example, Nitya, if you go to this particular link, the link that I sent in the chat, okay, in this link it is written what are the different tags, or what are the different inputs, or what are the different arguments that Docker push command takes. Docker push command only has these options, -in and this. Whereas let us talk about a command called build. So if you go to Docker build command has a tag called T, which is here. What does T mean? T means tag. T is the version kind of your Docker thing. Okay, T is the version of that. Is that making sense? Cool. So that is how. It's not that okay, T will be present everywhere. You go to that place and you see what it's doing. Okay, super. Cool. So my Docker image has been uploaded. Now because my Docker image has been uploaded, if I go to my Docker hub, which is here, where is my Docker hub? Why am I not able to see this? Maybe let me open a new window, redirecting. I think here I should be able to see it. Okay, if I go here. So if I go here, let me refresh. Now all of you are able to see my product service master class. Are all of you able to open this particular link? Well, base image is uploaded by different users secured. So Pragya, whatever you are making public, again, obviously it is something public. If you don't trust the person who created that image, don't use that image. Create something on your own. Okay? But OpenJDK colon 11 is a verified image. That means Docker has itself verified that that particular thing does not have any bug. Is that clear? How did you push Docker image? I ran this command, right? I ran the command called Docker push. Okay, cool. Yes, you can. That is the beauty of Docker images. Okay, cool. Now my question is, now anyone on the planet, if they want to run my application, if they want to run my product service application, wherever they are, the only thing that they have to do is they have to run this command. That's it. Just run this particular command. For the people who have Docker already installed, just try to run this particular command. For example, let me just show the terminal. And what will I do in the terminal is, I will just try to run this command. Okay. Just wait a few seconds. Okay. This command is ready. Now, this command, Docker pull command, okay, has brought everything that is needed to run the application into my machine. After that, the only thing that I can do is I can do Docker run, and I will just say this and wait a few seconds. And do you see your Spring application is up? Were you able to see your Spring application automatically started running? That's it. You did not need to install Java. You did not need to do anything. That's it. Now, any one of you, if you need to run my application, the only thing that you have to do is you have to pull the image, and after pulling the image, you have to run which command? After Docker pull, what is the next command that you have to run? After Docker pull, what is the next command that you have to